this is where we left off, right? We had just kind of gotten up to this example, but hadn't really done much with it, correct? Is that right? Okay, so let's talk about this. So what we want to do here, this is really, really powerful stuff. We're going to take, what we want to do is we're going to use our calculator to come up with a really accurate and high power math model for this situation in this case, but it could be any situation. So what we've got here, I can't remember if we went through the story yesterday or not, but essentially what's going on, this photographer was hiking through the Grand Canyon. She took 7 days for a week. She took 7 days worth of photos. Each day she took a whole bunch of photos, and then after the trip she went back and looked through those and deleted the bad ones and kept the good ones. And so this tells us on a given day how many photos she took and how many she ended up keeping, right? So what we want to do then is we want to come up with a model that's going to make predictions about this. We have to decide first of all, though, which of these variables is going to be our x variable and which is going to be our y variable. And so if we think about this, and this is a really good thing to do in math, we want to think about this in terms of a graph, right? So if we were going to graph this, so there's my x-axis and my y-axis. Which of these two quantities goes on the x-axis and which goes on the y-axis? Remember from before, I think I put something on the board a while back where we kind of divided up the board, and we said that we had our x variables and our y variables, and another name for our x variables was input variables, right? And y variables are output variables. There's one other row that we could add to this that I think I actually had on there, but we didn't talk about it at the time. The x variable, or the input variable, we can also call the independent variable, and the y variable, or the output variable, is going to be our dependent. And did we kind of leave off talking about that yesterday, what the difference is? What we got there? Even if we did, let's just review that real quick. What's the difference between an independent variable and a dependent variable? In the name really gives it all away. Say it again. Okay. Okay, good. So the independent variable is the one that kind of stands on its own, and the dependent one is the one that's going to change based on that one. We're going to calculate from that one, right? It depends on this one. Okay, and that's always going to be our y variable. All right, so if we go back then to this screen, which of these two quantities is going to be the one that's going to be the independent variable? It's not totally obvious at first, but if you think about it, there definitely is one of those that should be independent. The other one's going to be based on the independent one. Say it again. Photos taken would be our x variable. That's our independent variable. And then based on the number of photos taken, we're going to try to be able to predict how many she keeps for that day, right? So we'd say this is our x, and that's our y, right? Okay, so now what? We know what our x variable is. We know what our y variable is. Let's put these in our calculator. So remember did we even start doing this at all? Okay, so where we go to do this. On our calculator, we're going to push the stat button, the statistics button, and that's going to take us to the statistics window. The statistics window is broken up into 3 different menus. Okay? We're not going to use the test menu, I don't think, all year, but we'll use the other 2 quite a bit. So the edit menu is where we're going to input or edit data. And almost always we're just going to use it to input the data, and that's it. So we're going to go stat, edit, either 1 or enter, and it gets us to there, right? So this looks like let me make this a little bigger. So this looks just like an Excel spreadsheet, right? Where you got columns and rows. The columns at the top, the headings are L1, L2, L3, L4, right, etc. That's where we put our data. So we're almost always just going to use two columns, one for x and one for y. And we always want to put the x variable in the column L1, and the y variable goes in the column L2, right? The easiest way to do this is to just, based on our data table, is to just start at the top of L1 and input the first value and then hit enter, and it'll jump you down to the next cell below that, and you just keep going until you've input all of the x variables. Then if you scoot over to the right, you can just go over and input the corresponding y variables. So what if you want to, I've already got the data in there, but let's just pretend this was bad data, and I want to, let's say I wanted to clear all the entries from L2. Do you remember how to do that? Did we talk about that? No, okay. So here's how you can do it. You just go up to the heading of the column and you hit clear. Now what sometimes people do is they hit delete. You don't want to do that. If you hit delete, it eliminates the column and it's gone, right? And so what's that mean? Does it mean you broke your calculator? And no, it doesn't. You don't have to buy a new one. It just means that you have to reset the window, though, if you do that. To fix that problem, to fix that error and get that L2 column back, you just go stat, and then in the edit menu, the last choice, set up editor. So you just go stat 5 and then hit enter, and it'll say done, and it just reset it for you. So now if you go back to stat, edit, there it is. Okay, but let's pretend I wanted to just clear all that data. I just go up to L2 and hit clear, enter, and it eliminates it all, right? And so then I would just have to put in my new data. So go ahead and do that. Put in the photos taken in column L1 and put in the photos kept in column L2, if you haven't already done so. Okay, once you get all that stuff in there, now there's our data. There's a ton of stuff on the calculator we can do with that. First thing we're going to do is let's just build a scatter plot. So I'll show you how to do that. So on your calculator, we're just going to go to one time. I want to show you what this looks like and where it is. And so if you ever need to go in, like later in the year, we'll have to go in and make some changes here, but not now. Notice that the stat plot is behind the y equals. So we hit second, and then push this button and we get stat plot screen. There are 3 stat plots on there that we can build, and then we can turn all the plots off or all the plots on by hitting 4 or 5. Okay, let's just go to plot number 1. So let's hit enter, and this is the menu, or I guess they call it the wizard, that sets up plot number 1. Notice what all the default settings are. It happens to be that the default settings are exactly the ones that we want for doing a stat plot like we want to do. So we really don't have to do anything unless you've previously changed this setting, which nobody has. We're fine. What do those mean though for future reference? Well, the first row is obvious, on or off. Second row is the type of data plot that you want to do, and those little icons represent the different kinds of plots. So the first one is stat plot, second one is line plot, third one is histogram. The next 2 are the 2 different kinds of box and whisker plots. And then the one at the end is, I don't know what that is, maybe a frequency diagram. I don't even know. I've never used it. We're going to want the default, which is the scatter plot, the one on the far left. The X list, like we said, the X variables go in L1. The Y variables go in L2. The mark, we want to choose that first one, which is a box. Make sure that one works, shocks. A lot of those have dead batteries. So the mark, you want to use the box. The other ones you can't see very well. Color we won't mess with. You could change it if you wanted to, but no need. So we can just get out of there. We didn't really have to do anything. So we'll just quit. And instead we can just go up to y equals. So on y equals, notice what we've got here. We've got all these different y1 through y9. Those are different functions that we could graph. Different lines. We could put in parabolas, whatever. So we can put in up to 9 at a time. We'll probably never put 9 in at a time, but you can. The 3 plots that you can choose are at the top. Now, mine happens to be turned on. I'm going to turn it off so it looks like yours. So now nothing is turned on right now. But if I want to do a scatter plot, all I have to do is go up to plot number 1 and highlight it to turn it on. Okay. Now the calculator, we're telling it to graph the data that we input as a scatter plot. But there's one other issue we have to deal with. If I just happen to hit graph, this is likely to be what you get. That's sort of the home screen for graphing, but I don't see any of my data. The reason I don't see any of my data is it's not there. It's in a different part of the XY plane. If you go to the window, it tells you exactly what the size of the graphing window is. Well, the X minimum is -10, so the left edge of the screen is -10, the right edge is +10. The X SCL stands for X scale. That means where are the hash marks? Every one. They go by ones in the default. The Y minimum is -10, the Y max is +10, and the Y scale is 1. So if I look at my graph, that means that that's X equals, there's the X axis, right? There's the Y axis. That's X equals -10, that's X equals +10, Y equals -10, Y equals +10. But none of my data is there, right? The X values are really big, right? The X values, the smallest one we see is 117, and the Y values are also pretty big, so they're not even on the screen. So do I have to go choose the window based on my data? No, I don't have to. The calculator will do it for me. Real quick, if you got, remember when we're in here, this is something I really do care about. When we're in here, I don't want to see any earbuds or anything. Put those away if you got them. We can let the calculator do that for us. If I go to the zoom menu, look at the 9th option, zoom stat. That's really useful. Now, zoom stat is going to take the data that we input and it's going to size the window perfectly so that data all shows up. So all I have to do is hit, after I input my data, I turn on turn on plot 1, I just hit zoom 9 and look what it does. It spreads my data out on the screen so I can see it. Okay, that's pretty cool. There's our stat plot. If I want to trace through and see what the coordinates are of each of those points, I can actually just hit trace and look what it does. If I hit left or right, if I hit left, oh, maybe I hit, it's not doing that. There we go. So if I go through this, yeah, it's just going through the plots in the points in order that I enter. So there's the first one. Look at the bottom, the X and Y values. Those are the ordered pairs, right? The first one had an X value of 17 and a Y value of 25. Next one had an X value of 128, a Y value of 31, etc. One valuable thing about that is, later in the year when we get into start doing this more seriously, what if we have data that has a really nice distribution, but there's one point that's what we call an outlier that's a weird one that doesn't fit the pattern? You know, what probably happened there? What do you think? Like we're going to do this in my physics class, for example. We're going to do experiments in the next lab, and we have these computer sensors that'll take all the data for us. And if I display the data, and one of them is way off, what do you think probably happened? What do you think? Say it again. Data's not right. You know, either I made a mistake doing the experiment, or the sensor made a mistake, but somehow I got a data point that's an error, right? And so if we can locate those, we could actually find out what the coordinates are, and we could go back to the list and delete that point, right? See what I'm saying? So it's useful to be able to just trace along through these and see what the coordinates are of each one, okay? For now, we don't have to worry about that. Okay, so there's our data point. We want to try to fit this. They're telling us we want to find a linear regressional model. In other words, we want to come up with the best fit line. Now tell me, in the past, you've probably done some stuff like this, right? I'm guessing back in Algebra 1, you probably maybe plotted some data on graph paper and took a ruler out and tried to make a best fit line. Did you ever do that kind of stuff in the past? There's that's not really a very valuable thing to do, actually. The only value, glass soda there. The only real value in that is just that you kind of get an idea of what a best fit line should look like. But beyond that, it's pretty worthless. How come? If we did this process, if we all graphed this data on graph paper, and then we made our best fit lines, what are the problems with that? What do you think? It ought to be different. Yeah, plus there's tons of room for error, right? When we're plotting the data points, every time you put a data point down manually, there's going to be a little bit of error involved, right? When you draw the best fit line, There's another source of error, right? Because you're doing it manually. And probably the biggest thing is, are we going to agree on what the best fit line is? No, they might be close, but they're going to be different, right? And we want to have, think how valuable it would be if we could take a data set and we could come up with, A, the best fit line. So we know that we're getting the best possible one, but even more importantly, we can all agree exactly on what the equation of that line is. That's a pretty powerful process, right? There's a statistical process that does that. It's called regression. And back in the old days when you did regression, it was a really time-consuming process. The formulas are really big and ugly, and it takes a lot of time. But now, something as easy as your graphing calculator, that small, or even your phone will do it, honestly. We can come up very quickly with what the best fit line is. And here's how you do it. So once we get the data in there, we're going to go back to the stat screen, and we're going to scoot over to the calculate menu. So we go, I would just call this, when I remind you how to do this, we'll just say stat calc, which means we shift to that menu. And then which number are we going to choose? Which is the one we want, probably, for linear regression? Well, we could use, say it again? 9 is actually logarithmic regression. It looks like linear. 8 would work, but probably even better than that. That one works fine. 4 is probably the best one, and here's why. Because the form of the linear regression model in number 4 looks like mx plus b, doesn't it? Right? They call it ax plus b, but a is just the slope instead of m. We know that that's the slope, though, right? So we're going to choose 4. So we'll do this a lot. We say stat calc 4 is what we remember as the keys to get to linear regression. Okay, if I hit stat calc 4, if your operating system is up to date on your calculator, this is what you should see. Okay, if you don't see that, it just means that you need to update your calculator, which is really easy to do. All you have to do is just plug in your USB cable, just Google at home, just Google, how do I update my TI-84? It'll send you to the right link. You can download the latest operating system and load it onto your calculator. And it's like getting a new calculator for free. But if you buy a new one, like a lot of you are probably hopefully going to be doing here right away, it's going to obviously be loaded up with the newest operating system. Okay, so what's this mean? Linear regression. So x list is L1. Check, we know that, right? That's what we did. We put our x variables in L1, we put our y variables in L2. Why is that even there? Well, what if you wanted to change it? What if we had gone back on our stat edit screen? What if we had filled up column L1 with the x variables, and then we had put y variables in L2 and put maybe a different set of y variables in L3? Well, here we could say, okay, well this one we want to build from L1 and L3. We could control that. Very seldom will we ever do that, though. Usually we're just going to use the defaults, L1 and L2. So we don't mess with those. Frequency list, don't even know what it is. So skip that. Store regression equation. We'll get to that in a second. But if we just go down and hit calculate, I want you to see what this does before we do anything else. Okay, it does that. Okay, gives you lots of good information. Now, raise your hand if you don't see the R squared and the R on your screen. Anybody got that? Okay, if you don't see that stuff, here's what you have to do. You go into mode, and you go down to where it says stat diagnostics, and you want to turn that on. Okay, everybody see that? So mode, go down to this row right here where it says stat diagnostics, and make sure that's on. Anybody not see that needs to? Okay, good. Turn that on, then quit, and then just go back to stat calc 4 and just scoot down to calculate and hit enter. And now you should see the R squared and the R, and those are important. Okay, everybody got it? Did it show up, Ryan? You showed up too? Okay. So what do those mean? So our model is y equals ax plus b, so a is the slope, b is the y-intercept, and here the calculator is giving you the values of the slope and the y-intercept, right? On your assignment that's up there now, I think when it asks you to input the linear model, I think it wants you to round those numbers to 2 decimal places, but that's where you'll get the numbers. So that stuff, obviously, that's giving you the model. What about this other information, the r squared and the r? The r squared, we don't care about the r for now. We'll talk about that maybe later, but we really don't care about that. The r squared is important, though. The r squared is telling us the strength of the correlation. The way you can think about that is like as a percentage. So for example, if I take this decimal and think of it as a percentage, about what percent is that? 0.719. What's that? What do I do to make a percent out of a decimal?
72%.
Say it again?
72.
About 72. I just moved the decimal 2 places to the right. Okay. So it's about 72%. Well, what's that mean, 72%? That means that the points, this isn't exactly right, but it's a good way to think about it. It means that the points are about 70, the fit is about 72% of perfect. Okay. A perfect fit, if it were 1.0, if it were 100%, that would mean that all the data points were exactly on the line. That's rarely ever going to happen. But this would mean that they're off a little bit, but it's not bad. Okay, it's not great, but it's not bad. Like if we got a fit of like 20%, that's horrible. That means that a linear regression model doesn't work at all. It's not matching this at all. This means it matches it fairly well. Okay, and you'll get a feel for that. The more of this you do, the more you'll get a feel for what that number means. So there's our model, but there's something else that's important to do. What we really want to use this model for is making predictions. So let's go back to our data chart for a second. Let's say that we want to make a prediction. Let's say that if this photographer goes out and shoots 150 pictures, we want to make the best possible prediction of how many she's going to keep. Well, how could we do that? Well, one way would be we could write down this equation, y equals a, that number a, times x, plus b, and then we could plug in values of x on our calculator and see what y is, right? That's kind of a time-consuming process, though. There's a much easier way to do this with our graphing calculators. Instead, we can actually have the calculator draw the linear regression line, and we can use the graph to answer all these kinds of questions. So how do we do that? Okay, we go back through the same process. If we go stat calc 4, so stat calc 4, and get to the linear regression wizard like we had before, we're going to do one thing. Instead of just hitting calculate, we're going to go down to the store regression equation line, and we're going to store that as y1. So where do we get the y1? I'll show you. There's two ways. I'll show you like the official way to do it, and then I'll show you a shortcut. So the official way to do it is you go to the variables screen, you scoot over to the y variables menu, and then you just hit enter for function and choose whichever one you want. So we would just hit 1 or enter, and it puts a y1 there. Okay. Let me delete that. The other way to do it, the shortcut way, is this. If you just hit alpha F4, it jumps you up to the, and notice if I hit alpha in any one of these function keys, it pulls up a little soft menu at the bottom where you can see, okay, that's the fraction key. So if I go to F1, I get all my choices for fraction templates. F2 is going to be all the function templates, and F4 is going to be all the y variables. Okay, so alpha F4, and then I just type whatever number I want based on the y value, right? So we want y1, so we'll just hit 1 or enter, and it pops that in. Okay, does that make sense? Questions on that so far? Same as I did before, only I just added that y variable there, the y1. Now if I go down and hit calculate, look what it does. Nothing changed from before, same exact answer, but if I go up to the y equals menu, look what it did. It dropped that equation for that line into y1. And so if I hit graph now, there it is. There's my best fit line. Okay? That's really powerful because now I can use that line to make predictions. So what did we say, 150? If we want to take, for example, we want to make a prediction. If she takes 150 photos, how many does she keep? All I've got to do is look on the line where x equals 150 and see what the y value is, because the y value is predicting how many she keeps, right? How do we do that? Once again, I'll show you the official way, and then I'll show you a shortcut. Anytime you have a graph, and we're going to do this all year, anytime you have a graph that you want to use the graph to answer questions, get information from the graph, you just go second calc and it takes you to this calculate menu where there's all this stuff you can do for the graph. For example, you could calculate, well, we talked about zeros yesterday, right? You could calculate the zeros, the exact zeros of a function from its graph. You could find minima and maxima. We talked about those yesterday, right? You could do all that stuff for graphs. We're not going to do any of that today. The only one we want is value. So I'm going to hit enter or 1. And then notice it prompts me to type in an x value. So if I type in 150 and I hit enter, look what it does. It tells me that for the function y1, when the x value is 150, the y value is 38.31, blah, blah, blah. So rounded to the nearest whole number, what would that be? 38, right? So the prediction is then the most likely number of photos that she's going to keep is 38. Okay? Here's the shortcut for that. The shortcut is I can just hit the trace button, and then the one thing I have to do in this case, I have to hit trace, and I can't just type a number because at the top it says, okay, right now we're on plot 1, which is list, L1 and L2 are the data points. Well, look, the cursor's on one of those data points. I want to get to the line, not the data plot. So to shift from the data plot to the line, all I do is hit the down arrow or the up arrow. And now it shifts me to Y1. And then I can just type in whatever number I want. So if I type in 150 and hit enter, I get the same thing. Okay? So I've got a question for you then, and then I'm going to let you go on this stuff. What about this one? Let's say we want to make a prediction, and this is really an important point. So just hold tight, really focus here for another 5 minutes or less, and then you're good to go. I think the assignment will be easy. Let's say that she goes out the next day and she shoots 157 photos. That's a number that's on our data table. What's the most likely number she's going to keep? What do you think? Is it 52? When she went out and shot photos during her trip, when she shot 157 photos, she actually kept 52. So is that my best bet, being as it actually happened? Kind of seems like it, doesn't it? But it's not. Here's why. It's probably not. It might be, but it's really unlikely. Answer this for me. If she goes out tomorrow and shoots 157 photos, do you think it's likely she's going to get exactly 52? Probably there's going to be some variation, right? Okay, well the whole point of this model is, and there is a lot of variation. Look, things bounce around quite a bit. The whole point of this model is we're going to take all of this data together, and by building this model, we're going to kind of subtract away all that variation, right? So even though she took 52, or she kept 52 on that day, she shot 157. That's really not the most likely value. It just happened to bounce in one direction that day by a certain amount. Okay? How do we find the most likely value? Well, we use our model. So we just go up to our model, and we'll just go trace, scoot down to Y1, and type in 157, enter. So what is it? If I round the Y value to the nearest whole number, 40.6, what would it be? Excuse me, 41. Good. So it's quite a bit off, right? She's more likely to shoot 41 than 52. Even though she did that one day, she shot 52. That's probably one of those data points that's way off the line, right? She's most likely to keep 41. Make sense? Okay? I'll let you go. Grab a Chromebook, get cranking. I've got all the assignments are up. I up